Question 4. 3-methylbutanol is a compound that is found in low concentrations in many types of food. Structure is shown. Draw a structural formula for a ketone that is an isomer of this. Right, so I would go with the easiest one, to be honest. 1, 2, 3, 4, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then just make it a ketone. Fill in your hydrogens. Obviously write in the H's in an exam. That would work. And it is a structural formula, they're not asking for a name. Your other option, just have your 5 and put your ketone on the middle one. And I suppose you could also do a branched one. Put a ketone on and take one of your methyls off the side. However you want to do it, but genuinely I think that's your easiest one. Okay. Name a reagent that could be used to distinguish between 3-methylbutanol and a ketone. So you should know that if you take an aldehyde, you can oxidize to make the alkanoic acid, or sorry, carboxylic acid. If I'm just going I can't spell boxylic. There we go. If we're just using aldehyde as the name, and if we're going ketone, we know that we can't oxidize. So I'm looking for any one of the reagents that we have as our kind of basic list. So fillings, toluenes, acidified, that's not how you spell it either. There we go, acidified, dichromate, all of these being oxidizing agents that we can use for that. Okay. Name the strongest intermolecular force that occurs between 3-methylbutanol molecules. Okay, so we have quite a lot of polar bonds in here. The strongest one polarity-wise is that one. So what we have is permanent dipole to permanent dipole. Methylbutanol is found in olive oil. Explain fully what can happen to 3-methylbutanol that would cause the olive oil to develop an unpleasant taste. Okay, well, it's actually just what we've put up here. Okay, so what you need to say is that we can oxidize this from the aldehyde to the carboxylic acid, but it's asking fully, so you're going to take the actual molecule. So take your 3-methylbutanol. Where were we going? So if we oxidize this, okay, we're going to change this to butanoic acid. Okay. But 3-methylbutanoic acid, let's name it properly. So you're going to oxidize to 3-methylbutanoic acid, and these acids have a sour taste because it's an acid and therefore it would be unpleasant. Okay, so the oxidization perfectly to 3-methylbutanoic acid, not just saying it oxidizes, and then you have to say that acids have an unpleasant sour taste. Okay. For E, 3-methylbutanol can be used as a reactant in the production of other compounds. Got a little one going on here. Explain why step 1 is described as a condensation reaction. Okay, so what we've done in step 1 is to take two molecules, join them into one bigger molecule with the removal of a small molecule to do that. That is a definition of a condensation reaction. So that's what you need to say. That you have taken joined together molecules with the removal of a small one, and water is the small molecule. Give a systematic name for product A. Okay, so it will just follow our normal things. Find the longest chain that you can. That'll do. Okay. Meth, eth, prot, but, pent, hex, hept. So we've got hept. And we've got a ketone in here, so that's going to determine the numbering. That's going to be carbon 1, 2, 3, 4, 5, 6, 7. So we've got heptan 2-one, and we've got a group of number 6, and it's a single carbon, so 6-methyl heptan 2-one. There we go.